So we have the following situation. We are on a ship course of 45 degrees and my tropical storm has a path of 280 degrees. So let's just mark this here in the chart. This is 45 degrees. That is my course. And the ship path is 280 with 40 knots. The bearing this ship to tropical storm is 70 degrees. So let's see. This is 70 degrees and the distance is about 600 nautical miles away. So taking the 600 nautical miles, then I'm coming up to this position here. So that is the position of my tropical storm. The tropical storm has a semicircle of 200 nautical miles. So let's place the 200 nautical miles here around and adjust it. So to see that we get really the 200 nautical miles. So that's about the 200 nautical miles. That is actually the semicircle of this. And the tropical storm is now on his path, as we said, of 280 degrees with 40 knots. It's about like this. So that is the tropical storm. So with my speed, I do 300 and something nautical miles per day. So which means I will be about here on the next day. That is around about my position on the next day. And the tropical storm would be about here. Yeah, that would be the position of the tropical storm. Somewhere here. So, and then this semicircle, we take again this 200 nautical miles. If we say, okay, he would have found about 200 nautical miles. Oh, adjusting. So that would be the position the next day. So you can see that I'm really running into this dangerous semicircle where I can expect very high waves and high swell for sure. So therefore, an alteration of the course is actually the only solution and the only control measure what I will have. So therefore, if I now alter my course here, then I would be not in this dangerous semicircle. So here I can even go a little bit more further to the north. So that is actually how it looks like if we are looking into this situation. So the only one I have, I'm coming out here from my sombrero passage or whatsoever, and then I have omitted to alter the course. This is a very normal situation what we are facing in the tropical storm season here in the North Atlantic. So now let's see how it looks like if we are doing it on a plot. So we are on a course of 45 degrees, we said, and we have a speed actually of 15 knots. So let's do this here. 45 degrees with 15 knots. 45 degrees with 15 knots. So that is my part. I have 70 degrees with 600 nautical miles, we said. And that is actually the position of my tropical storm. We had 70 degrees and 600 nautical miles. This is here. And with a semicircle of 200 nautical miles. So let's place the 200 nautical miles around here and let's do the adjustment accordingly. So actually, if you do this on a plotting sheet, you do not have to adjust this. But here on my electronic paper, I have to do the adjustments accordingly, because I have not such a fine tuning than on a radar plotting sheet. So now the course, as we said, is 280 degrees with 14 knots. So let's say 280 degrees, 14 knots. It's here. So that is actually the course. So put it in here. So that's the course of the tropical storm. So what we are now doing, we like now to know what is the course I have to steer and courses to be avoided. Therefore, we are considering that we are working with the circle of uncertainty, which is 1/3, because it is not on the it's still on the equatorial path. So 1/3 of the speed, it's about 5 knots. So then the circle of uncertainty is 5 knots. So here 280 degrees again, we are placing it the end of my vector, my speed vector. And now here around of this, we are taking now this with 5 knots, the semicircle. So let's put it around. So adjusting it again. This is only for me if I do this on a digital base. So now we are connecting the end of the tangent of the semicircle here of this sorry of the circle of uncertainty with my vectors is 1, and I'm now parallel shifting it so it's to the center. So there you see I'm running directly into this, and the other one is here. So also parallel shifting for the second solution. We already know there's always 2 solutions. And you see I'm also running directly into this. So which means the courses, what we can say, the courses to avoid, courses to be avoided is, first of all, here 52 degrees, or let's say we are doing it from 2. And here we have to see that I have here clearly about 78 degrees to here 52, but actually my course is 45 degrees. So if it's 45 degrees, if I continue with my course here, I will cross this, therefore 45 degrees. That are the courses to be avoided. So now for me important courses or course to steer to avoid the dangerous semicircle. So let's see what courses can be avoided, or what courses we have to steer to avoid them. For this, I go here tangential to the semicircle. So tangential to the semicircle. So that is actually the course I have to steer to avoid the 200 nautical miles. That means if I will do this correctly, I can save. Courses to be steered is from here downwards. I can steer the courses to avoid. So here, courses to be avoided. That is actually 95 degrees, 5 degrees, and more. So then I will be no longer in this, or will avoid the dangerous semicircle of 200 nautical miles. So we can write down to avoid the dangerous semicircle of 200 nautical miles. So that is actually what I have to do. So to alter my course, and really the same we got already in the other drawing what we have seen. So we have seen in the navigational chart that I have roundabout the same. So between here 85 and 90 degrees, but not so exact. But here this is very exact now. So 95 degrees is the course to avoid the tropical storm and to be on the safe side. Okay, thank you for watching this video, how to prepare this and how to analyze the situation, not to run into the dangerous semicircle of the tropical storm.